Mastercam X3 can import SOLIDWORKS solid history data directly into the Mastercam Solids Manager, simplifying the machining process. When you open a SOLIDWORKS part file, click Options and select the Import Solids History checkbox. SOLIDWORKS has to be installed on the same system as Mastercam for the history to be imported. When you click Open, X3 connects to SOLIDWORKS and reads in the complete solid history. You can then edit the solid using the Mastercam Solids Manager. For example, you can suppress these pockets and channels for roughing operations. Mastercam X3 simplifies your manufacturing needs with intelligent data exchange. X-Form drag is enhanced in Mastercam X3, simplifying user interaction and eliminating mouse clicks. There is no need to press Apply to place copies. Simply press the New Multiple button and continue to place as many copies as you need. X3 makes it easier to manage your underlying wireframe geometry when using X-Form to move solids. When you use X-Form Move on solid data like so, you are prompted to either have Mastercam automatically move the associated wireframe, even if it is on a level not being displayed, or make a copy of it. Select Yes to move the wireframe geometry, or No to make a copy. The new X-Form Move to Origin helps with automating part setup. The origin for this part has to be changed before machining. Simply click the Move to Origin button. Follow the prompts by selecting the point you wish to move relative to. Mastercam automatically moves all the data to the system origin relative to the selected point. This part is now ready to machine. Mastercam X3 helps you easily modify your parts with quick, simple functionality. Mastercam X3 introduces a suite of 2D high-speed toolpaths. These 5 2D high-speed toolpaths can help make your current processes more efficient and automated, and minimize programming and cycle time. The Core Mill toolpath requires less CAD knowledge and model preparation from the programmer. Core Mill automatically machines standing bosses and cores in one easy step, generating smooth, free-flowing motion. This part was programmed with Mastercam's 2D Contour toolpath. It required quite a few operations and additional geometry creation to minimize air cutting and cycle time. Here's the same part programmed with X3's new Core Mill toolpath and no additional geometry. Notice the efficiency of the stepovers within the Core Mill toolpath. Each pass slowly takes on the final shape of the part as it steps over while approaching the final pass. Also notice that it only took a single operation to machine the part. Area mill toolpaths can produce smooth, clean motion when machining pockets. You can control the smoothness setting on the Cut Parameters page to create the best path for your tools to take, avoiding sharp corners and direction changes. Smooth helical entries and tangent stepovers also create efficient motion for the machine tool. The 2D high-speed rest mill toolpath targets material that previous toolpaths left behind. Rest mill ensures that the tool safely approaches leftover material using either helical entry or vertical arcs. Rest mill motion can be smooth, resulting in longer tool life and less wear on the machine tool. X3's blend mill toolpath morphs between two curves generating motion previously unavailable in 2D toolpaths. These toolpaths generate fewer retracts and toolpath operations on these difficult-to-machine features. Blend Mill also allows you to use the full depth of the cutting tool, utilizing more of the cutter's flute length and resulting in less cycle time and tool wear. The Blend Mill toolpath can run along two contours like so, or across two curves, generating the best motion for the job. The Peel Mill toolpath has been enhanced for X3. Peel Mill efficiently machines open slots and channels, utilizing the full depth of the cutting tool. X3 introduces micro lifts for Peel Mill, which raise the tool up a very small distance to avoid dragging across the floor of the part on the back passes. This motion could affect the finish on the floor and generate unwanted heat. You can set the microlifts options on the Cut Parameters page. Here's the microlift in the back plot, ramping for 100 thousandths of an inch to the 10 thou height input. The tool stays at the height and approaches the program cutting depth as it descends from the 10 thou height using another 100 thousandths of an inch ramp length, before entering material and making the next peel cut. Mastercam X3's new 2D high-speed toolpaths get the job done. Mastercam X3 introduces new 5-axis edge blending functionality. Edge blending helps create better finishes where toolpaths meet along surface edges. For example, edge blending improves the blending between 5-axis toolpaths when headporting. This toolpath had a 30-degree exit blend defined at 3/8 of an inch past the final toolpath pass. The generated motion creates a tapered cone effect that moves the tool away from the surface edge as it tapers 3/8 of an inch past it. The second toolpath coming in from the other side will use the same blending settings, creating a smooth transition on the surface edge where the two toolpaths meet. Mastercam's advanced multi-axis toolpaths have the power to convert standard 3-axis toolpaths into efficient 5-axis motion, allowing you to program with shorter, more rigid tools. Here's a standard 3-axis HST waterline toolpath. This toolpath would require a very long tool to safely machine this model. Here's another 3-axis toolpath generated using the HST pencil toolpath type to clean out this 50 thou radius. Again, this small cutter would have to hang out quite a bit to reach the radius feature. Mastercam can convert these 3-axis toolpaths into 5-axis toolpaths, allowing shorter, more rigid tools to be used. The Advanced Multi-Axis Toolpath Suite offers a Convert to 5-axis toolpath. Define a shorter tool on the Toolpath Parameters page and use the Tool Axis Control page to define the tool axis. The output is set to 5-axis, but the tilt angle is locked at 0 degrees relative to the Z-axis, in essence using a vertical machining angle. The Gouge Check Parameter page is set to allow Mastercam to use 5-axis motion to tilt the tool to avoid any collisions between the selected tool components and the check surfaces. Mastercam processes this toolpath and tries to keep the tool axis vertical where it is safe and use tilt motion to avoid any collisions. Here's the toolpath in the back plot. Notice the 3-axis motion. Watch as Mastercam tilts the tool to avoid a collision with the check surfaces. As it progresses further down the part, it can safely return to 3-axis motion in certain areas. The pencil toolpath can also use a shorter tool, and the tool axis is locked to 25 degrees on the tool axis control page. The gauge check page again allows Mastercam to tilt the tool further to avoid any collisions relative to the defined clearance distances. Here's the pencil toolpath in backplot after being safely converted to 5-axis motion. Mastercam X3's powerful multi-axis capabilities are second to none. Mastercam X3 introduces feature-based machining, or FBM, for both milling and drilling. You can use FBM either as a fully automated tool or as a manual tool, allowing you to customize your output. FBM can tackle simple models or very complex models, simplifying the programming process. With a single click, FBM automatically detects features and communicates information about those features. Press the OK button and FBM generates the necessary toolpaths to machine the features according to your settings. Once processed, you can edit or verify the toolpaths using Mastercam's backplot or solid verification tools. FBM Mill automatically machines solid models consisting of vertical walls and flat floors. FBM Mill utilizes X3's new 2D HST toolpaths to generate smooth, efficient motion for your conventional or high-speed machining needs. When you press the Detect button, FBM will detect all machinable features and report detailed information about those features. You can define how FBM chooses tools it uses, or can load the tools manually for FBM to use for the different operation types listed here. You can press the OK button and allow FBM Mill to use the defaults, or you can change any settings found on these parameter pages to customize the resulting output. You can even disable certain operations like floor finishing or wall finishing. The resulting toolpaths generated by FBM appear in the Toolpath Manager and can be edited like any other manual toolpaths generated, giving you the flexibility you need. Here's the resulting FBM Mill operations in the Solid Verify. Mastercam's FBM Mill gets the job done faster. Just like FBM Mill, FBM Drill automatically identifies hole features in your solid models. When you press the Detect button, FBM finds all holes in the model and populates the features list. You can choose to detect holes constrained to a single tool plane, or allow FBM to detect holes on all planes. Mastercam's FBM Drill includes options to handle split holes, coaxial holes, and deep drilling conditions. Enable pre-drilling to use multiple drills to approach the hole finish size. Simply press the OK button and Mastercam processes all the necessary drill toolpaths in one easy step. Here are the toolpaths in the Mastercam Solid Verification. FBM Drill can also recognize SOLIDWORKS Hole Wizard information. These hole features were created using the SOLIDWORKS Hole Wizard. The 4 outer holes are simple through holes, and the inner holes are half 13 tapped holes. Press the Detect button, and FBM identifies all 6 holes. Press the Select SOLIDWORKS File button, and select the SLDPRT file from SOLIDWORKS. FBM uses the Hole Wizard information in the SOLIDWORKS file to identify the design intent of the hole features. Press the OK button and Mastercam generates the proper toolpaths to drill the features. Make more parts faster and simpler with Mastercam X3's feature-based machining.